a comprehensive guide to soldering various electronic components. Today, we will learn how to solder a wide range of surface mount device SMD and through-hole components onto a printed circuit board PC using a soldering iron. We will follow a step-by-step process to ensure a better, more reliable soldering technique. Let's begin by identifying the components we have. Component inventory. We have several types of capacitors. 2 electrolytic capacitors, 1 tantalum capacitor yellow, and 3 ceramic capacitors. Next, we have multiple SMD resistors 0603 package. There is also a voltage regulator, several diodes, including Zener diode, a transistor in an SOT-23 package, and 5 integrated circuits ICS in different packages. A quad flat package, QFP-IC with 16 pins per side, 64 pins total. 4 small outline package SOP, 1 with 14 pins per side, 28 pins total. 1 with 10 pins per side, 20 pins total. 1 with 8 pins per side, 16 pins total. 1 with 4 pins per side, 8 pins total. Now, let's proceed with the soldering process. Step 1. Soldering. The 0603 SMD we start with the smallest components, the 0603 package SMD. For the 4-resistor footprint, we will first apply a tiny ball of solder to one pad on each pair. This helps lock the component in place. Apply a light layer of solder flux to the pads. Flux is crucial as it cleans the surfaces, prevents oxide formation, and ensures a smooth, clean solder joint. Using tweezers, carefully pick up one resistor and place it on its designated footprint. Gently reflow the pre-applied solder ball with the iron to lock the resistor in place. Repeat for all 4 resistors. Now, solder the opposite side of each resistor. Apply a small amount of solder to the tip of your iron and touch it to the junction of the pad and the resistor's end cap. The solder should flow smoothly due to the flux. Clean the area with isopropyl alcohol, IPA, and a brush to remove any residual flux. The resistor should now be perfectly soldered with a shiny concave fale. Step 2. Soldering the ceramic capacitors C1, E6. The process for these is identical to the resistors. Apply flux to the capacitor pads. Tin 1 pad slightly. Use tweezers to place the capacitor, heating the tinned pad to lock it. Solder the opposite side. Clean with IPA. Ensure the component sits flat on the board. Step 3. Soldering the tantalum capacitor C1A. Crucial polarity note. Unlike normal capacitors, tantalum capacitors must be connected in reverse bias. The marked side, usually a line or plus sign, is the positive terminal. The PCB footprint will also have a marked positive pad. You must match these. Tin the positive pad on the PCB. Place the capacitor, aligning its positive mark with the PCB's positive mark. Reflow the solder to lock it. Solder the negative side. Clean and inspect. Incorrect polarity can cause the capacitor to fail violently. Step 4. Soldering the electrolytic capacitors C19 and other. These are radio through-hole components with clear polarity markings and negative stripe. Insert the capacitor's leads into the correct holes. Ensuring the negative lead marked by a stripe on the capacitor body goes into the negative pad, often marked with a shaded outline. Bend the lead slightly on the other side to hold it in place. On the solder side bottom, tin 1 pad. Touch the iron to the tinned pad and the lead simultaneously until the solder slowly bring the capacitor body down to sit flush on the board while the solder is molten. This ensures a neat, low-profile installation. Solder the other lead. Clip the excess lead length. A proper solder joint should be smooth and cone-shaped. Step 5. Soldering the Zener diodes D23 disease. Polarity nochi, the black line on a Zener diode, indicates the cathode negative side. Zener diodes are typically used in reverse bias to regulate voltage. Tin 1 pad on the PCB footprint. Place the Zener diode, ensuring its cathode line aligns with the cathode marking on the PCB. Usually a line or K. Apply flux and solder both sides. Clean with I. Step 6. Soldering the signal. Diodes. D3 and other. Polarity. Noche diodes allow current flow in one direction. The cathode is marked with a line on the body. The PCB footprint has a cathode mark in a line or a symbol matching the diode stripe. For diode E3, the PCB uses a footprint shaped like the diode symbol. The arrow part is the anode positive, and the vertical line is the cathode negative. Match the diode's cathode line to this. Tin 1 pad, place the diode, and solder it in place. Repeat for the other. Diode always double-checking polarity. Step 7. Soldering the SOT-23 transistor. Transistor footprints have 3 pins: emitter, base, collector. Correct orientation is vital. Tin 1 pad, for example. The base on the PCB. Apply a little flux. Using tweezers, place the transistor in its footprint, aligning its marking with the PCB's marking. Reflow the tinned pad to lock it. Then solder the remaining 2 pins. Clean and inspect. The solder joints should be clean without bridging between the closely spaced pins. Step 8. Soldering the QFP64. I see this as a fine-pitch component requiring precision. Alignment is key. The IC has a white dot mark in pin 1. The PCB has a corresponding dot or notch. Align them perfectly. Do not apply solder yet. Carefully place the IC, ensuring all pins are aligned with their pads. Tack soldering. Apply a tiny amount of solder to 1 pin on a corner to lock the IC in place. Check alignment again from all angles. Tack solder the diagonally opposite corner. Readjust if needed. Soldering all pins. Apply flux along the rows of pins using a fine tip and thin solder wire. Drag the iron carefully along each row. The flux will help solder flow onto each pin without creating bridges short circuit. Clean thoroughly with IPA and inspect under light. Use a magnifier to check for any bridges. If found, apply more flux and use a solder wick or the tip of your iron to remove the excess. Step 9. Soldering the SOP, ICS 16, 28, 20, and 8. The process is similar for all SOP packages. Align pin 1. Every SOP IC has a dot or notch for pin 1. The PCB has a matching marking a dot, notch, or angled corner. Align them. Tack solder. Lightly tin 1 pad on a corner. Place the IC in A and reflow that pad to lock it. For larger ICS, 28 pin, tack 2 opposite corners. Complete the soldering. Method A. Drag soldering. Apply flux. Carefully drag the soldering iron tip along the row of pins. This is efficient for multi-pin IC. Method B. Pin by pin. For beginners, solder each pin individually, ensuring no bridges. Clean and inspect. Always clean with IPA after soldering. Visually inspect each row to ensure every pin is soldered and there are no shorts. Step 10. Soldering the voltage regulator. This is typically a multi-pin through-hole or SMD component. Identify its orientation from the PCB silkscreen marking for pin 1. Insert or place the regulator. Tin 1 pin, pad and solder it to lock the component. Solder all remaining pins. Ensure a good thermal connection, as regulators can generate heat. Conclusion and final inspection. After soldering all components, perform a final visual inspection. Look for cold joints, dull, grainy, or cracked solder. Bridges. Solder unintentionally connecting to pins. Insufficient, solder a weak or non-existent connection. Polarity errors, especially for diodes, capacitors, and IC. Use a multimeter in continuity mode to check for shorts between power and ground. With practice, patience, and the right tools, a good temperature-controlled iron, thin solder, flux, and tweezers, you can achieve professional, reliable solder joints for any component on a PCB. Your engagement inspires us to create more detailed tutorials. If this guide was helpful, please like, share, and subscribe. Share your soldering experiences or questions in the comments below. Thank you for reading, and we'll see you in the next guide.